Alright, so let's get ready to program this workpiece. Not too much complicated stuff here. We will draw this one from scratch. Will not be importing a model. And this one covers a little bit of boring. So we'll drill this portion and bore this. So I guess the order of operations here, we'll take care of the OD out of, looks like 2-inch stock that I'm going to use for this. That's generic for our shop. We'll take care of the OD, part it off. And I'll probably leave so much so that it doesn't actually drop in the machine. We can actually break it off later. We'll flip it, grab it again, and we'll take care of the ID work. Alright, so let's get ready to draw this workpiece. Alright, so Mastercam's open now. Let's start drawing this workpiece. We're going to essentially draw it in half and revolve it. So look at our drawing. I'm going to draw our center line first, and then I'll start working on the diameters and these faces as we go. So get back into Mastercam, draw a line endpoint from our top plane centered over, and the length will be 3 inches. And then what I'll do is I will offset this line up half of the 1.5 diameter. So if we're going to offset 1.5 divided by 2. Offset it up, hit green check. I'm going to clear colors now. I will then draw the back face line here for referencing. Then we can offset this line in 1 inch from here to here. 3 inches minus 2 inches. So offset the line 1 inch. Hit green check, clear colors. Alright, so let's take care of our next diameter. Right now I'm going to go to divide and get rid of this leader line here, and it looks like I'll go to offset. Our next diameter is 1.220, so I'll go back into Mastercam. Distance 1.22 divided by 2. So click that up, apply, green check, and then let's take a look at the face. It looks like it's going to be 1 inch from this side or 2 inches from this side. So since I have this line drawn, I'm just going to offset it 2 inches from the right side. So I'll go to offset 2 inches from here to here. And then I will go into divide and start cleaning this up. I will also clean up this these details here so it sort of looks like our workpiece. Green check, and let's take a look at our next diameter we're going to create, which is going to be 845. Alright, so 845 divided by 2. So 0.845 divided by 2, and offset this line up here. I can clear colors, finish up by just drawing this line, which we're going to be messing with in a minute anyways, with green check, and then divide and clean up the inside of the workpiece. So now the OD is done and ready to be revolved, but we need to take care of the ID. Okay, so let's take care of the 1/2 inch hole first. Because that's all the way through. So we'll go to offset and we'll type in 0.25 and offset this entire line up, green check. Alright, now let's take care of, I'm going to take care of this depth first. So the depth of this pocket is 7/8 of an inch. Okay, so we'll go offset 0.875 from this edge, and then we will offset up the diameter, which happens to be 1 inch. Okay, right here. Alright, so we'll offset that up 1 inch. The only thing I'm going to look at here, I do have to add this chamfer, but this R40 Max, we'll create that with the insert we select. I don't think any inserts in the shop are greater than a 32nd of an inch, so we're not going to end up drawing that in. We'll have to take care of this chamfer though. So we'll take care of the whole diameter. So we'll go to offset 1/2 inch. Here to here, and then we'll use divide to clean up our geometry. So that is going to be what we're looking at. Last thing is this chamfer. So we'll go into chamfer entities over on the right here, and one distance is fine. The distance is going to end up being, if we look at the detailed view, 40 thousandths by 40 thousandths, so that's good. So that means that we can use one distance, that'd be 45 degrees, which works out. So we'll type in 0.040 from here to here. Alright, and we'll hit green check. So that should be right. You could always check this stuff. Again, you could right click, go to analyze distance from here to that point, and you know, we can take a look over in the specs here. It's 40 thousandths. All right, the other thing you could do, if you don't like working with that, if you go to drafting, you could force it to vertical from here to that end point. And if it doesn't snap, like it's not working for me, sometimes you can end up just going to vertical, and make sure you select the end points from there to there. 40 thousandths, so that's correct. And you could leave those on sometimes if I'm working with this. It's not often, but with drafting, usually I'm using angular a lot. But you can go in here. I also use a whole table as well. But you could leave these on a different level to help you in your part process. Not something I do a lot. It depends on the situation. But you know, don't be afraid to use these. You can consider drafting sort of like, it's not like smart dimension. Even this smart dimension is not quite. It's not like SolidWorks or a parametric program or a parametric type modeling. It's just not like that. I don't end up using that a lot. If I want to change the length of something, you should just right click and analyze entity properties. You can update it in here. But even then, sometimes it is faster to delete it. It depends on your methods. So I wouldn't quite worry about that, especially with something this simple. So that looks like that's pretty much right. I don't see anything I'm missing. So let's get ready to revolve this. So what we need to do is go into Solids, Revolve, and we're going to select this outside, okay, and hit green check. And then the next prompt is select a line to be used as the axis of rotation, which is the center line. And we get a good demo or a good preview of what we're going to be doing. So that looks good. We will now hit green check. And this workpiece is essentially ready to machine. So we'll put a little transition here, let you catch up, and we'll come back. We'll probably start by flipping this around and start to get into our tool paths. Alright, so let's get ready to turn this. You'll see I already have a machine group. I selected the generic Haas ST 4-axis lathe post. That is available on Blackboard. Machine, mill, make sure you get, lathe. Make sure you get the generic Haas ST. Don't use default. This will be fine for what we're doing, tool room mill or the turning center. They take the same programs. We're going to be programming like a turning center though, so from the back side of the workpiece. So for turning this OD, I just labeled my first toolpath group as Op1 OD turn. I also have my levels set. I want to set the solid as level 2 just to break it up. So this will be part, and level 1 will be wireframe. Okay, so I'll hide the wireframe for now. We don't need that. So let's rotate the workpiece around. So select the whole workpiece, and actually before you do that, make sure you got the wireframe too. So select everything, because you don't want to lose that. That'll give you one of the errors in the solids. You have to remove solid history and all that kind of stuff. So let's just move it together for this example. Go to dynamic, select this side, rotate the part 180, and then bring it over in the X, -3 inches. Alright, hit green check, that's what we're looking at. Alright, clear colors. And then I am going to go into levels and turn off the wireframe. So for right now, we need to think about not only our stock setup, but also think about, I like to deburr the workpieces in the machine when I can. And one of the simplest ways to do that is to draw the chamfers or radii on the workpiece. So what we're going to do is we're going to draw a little radii, 15th radii on each of these corners. So we'll go into solids, we'll go into constant fillet, select the diameters, not like that one. So go back into constant fillet. You could have hit clear selection, but I hit escape out of habit. Then hit end selection. And the fillet's going to be 15 thousandths. Okay, that's green check. So now we have a part that will be deburred after the finish pass, nice and smooth. So we'll go to top view. Let's get into our properties, go into stock setup. And the stock for this is going to be 2-inch OD. Let's say it's going to be, we could go 5 inches long. That'll be fine. And 20th margin on the right is okay. The margin on the right just allows you to see the facing. It's not really necessary. it depends on what you're doing. So we'll end up just leaving that for 0 for now. So we'll preview lathe boundaries. Looks good because we are facing the 0. So we'll hit green check. Next what we're going to do is go define the chuck jaws. We'll make sure that we are from stock. Gripping on 1.5 inches should work. We'll preview lathe boundaries. That looks good. Enter. And we are pretty much set up. So now we'll get into our turning operations. So we'll start with a facing op. We'll select our CNMG 80-degree insert. Spindle speed 200 slow. We'll just go to 500. That's still slow, but it'll be good for a learning, or people learning how to use the lathe. Max spindle speed of 2,000. I might even reduce that depending on when this is assigned in the shop, but for a programming class, that is fine. Feed rate of 10,000 should be okay for us. I don't think we'll get too choppy of a finish. It is only aluminum. Coolant's on, that's good. Facing parameters, everything there should be fine. We'll hit green check. There's our facing op. Alright, so let's rough the OD of this workpiece. So we'll go to roughing operation. We'll carefully select the first radius, change direction, and bring the chain over to the end of the workpiece here. Hit green check. Use the same tool. We will limit our max RPM to 2,000, spindle speed of 500, and feed rate of 10 is okay for this roughing op. Rough parameters. We'll do a 50 thou depth of cut, and minimum depth of cut of 1 thou. We're just going to equal steps so that it won't affect us. We'll leave 10 thou on X and Z. We'll have to be careful of the Z later on with the finish tool. I'll show you why. First thing, stock recognition. Make sure that is use stock for outer boundary. Lead in and lead out. The lead in is probably going to be okay. The lead out, I want to extend it by about 1/4 inch to allow for the parting tool. Not a big deal, but it does help. Otherwise the parting tool could hit the shoulder and things like that. I end up thinking if you're going to part it off and you're turning from a larger piece of stock, you want to part off the turned material, not necessarily from the OD of the stock. I don't know why you'd want to do that, but there's a lot of variables here, so this is what we're going to do for this one. So lead in, that's fine. That should be good. We'll hit green check. Alright, looks pretty good. Alright, we'll watch both of these run in back plot now. So here's our facing op. I'm going to slow it down so we can actually watch it. Here's our facing op. Sometimes you pause and I just go S. S and B. So that looks good. Roughing past the workpiece. That should give us room for our parting tool. Looks good. So now let's do a finish op. So I'll hide the visualization of those two tool paths, and I'll go to finish. Same chaining as the roughing. Green check. And for finish parameters, for the finish tool, I'll use this 35-degree tool for that, just to have a tool change be in this operation. Spindle speed, constant surface speed of 500, max 2,000. We'll go to a 3 thou feed rate for finishing. Everything here should be okay. The only thing that's going to change is going to be lead in, lead out. The lead out will extend it, but only by 0.240. And the reason for that is we go 250, since we left 10 thou on the faces. And actually, let's just turn that off for now, and I'll show you that. So we'll hit green check, and let's change that to 250. That's what we did with the first one. So let's make a match 250. The other thing I forgot about, this needs to be tool 2, so sorry about that. And station number, I would make a match. We don't have station number issues with our lathes at the college, but that'll work for us. Green check. So notice the tool is actually going past a little bit. So if we go into home and analyze tool path, and you'll see, if I move this thing out of the way, look how far the tool is going into the stock. See how it's gouging? It's going to squeal. That's a common mistake people make. That is because in the roughing we left 10 thou on the faces. So if we go back to parameters and lead in, lead out, change it to 240. And then if we go to our analyze tool path and put the tool right at the end, you will see that where the tool's doing the work is lined right up, right there. Okay? So that's important. It's not the end of the world, but it does make a difference. So we're good there. Okay, actually, if we look at this tool path, and actually just look at it in backplot to make sure it's flowing right. So it goes right to the edge, works around the workpiece. If I slow it down, you can watch it run. Looks good. Alright, now we could change the lead in and things like that, but I think it's okay for this operation. So this part is turned. Let's take care of the parting. I'll transition here. We'll take care of the parting in a minute. Alright, let's take care of the cutoff operation. So go to turning, and we'll go to the cutoff op. And I want to select the boundary, but you can't just go over and select this diameter because it's going to go to the center and you're going to have crash issues. So on situations like this, you have two options that I usually use. One is going to be draw a line here and then select the OD of the line. The other one is just hit the spacebar and then this little window up here comes up, and then you could type in where you want that point, and you could draw geometry this way. It's sort of old school, but it does work well. The first number you type in is X, second is Y, third is Z. They're all separated by commas. So we're going to go minus, if this is 3 inches, 3.015. And I want to leave it a little bit long because we are going to face this back side and up too. So leave it a little bit long because we are going to have a spud in the middle. We're going to end up programming this to part off in Mastercam. We would change it at the machine if we were going to leave it attached to break off by hand. The reason for that is when you work with the stock flip in Mastercam, it doesn't flow well. You can work around it, but it's a lot easier as far as Mastercam programming to, I guess, fake it out, which I don't like to do, but in this situation, it is definitely going to be easier for us. So X is minus 3 inches plus 15 thou, comma, in the Y is going to be 0.75, which is the OD of the workpiece, and then Z is comma 0. So hit enter, and you'll see, we move this out of the way, top view, that point is right there. So that worked out well. Now, for the tools, I have the parting tools selected. So if I get back into the lathe tools, that's lathe metric, lathe inch right there. And I have this cutoff tool selected, 1/8 of an inch. Now, the grooving tools could work. The question with grooving tools is typically they're not as long as a parting tool. This part's not that big a diameter, so we can get away with a solid shank holder. Any diameters larger than 3 inch, you really need a blade style holder, and I can show you those in the shop if you have any questions, but this will work for us. So hit green check, and I already have it in there, so I'm just going to X out of here and just delete that one. And I already renamed that tool 3. I'm going to go inches per rev, 2.5, spindle speed, 200 max is going to be, let's say, 1,000. And we are not parting all the way off. When we get to the machine, we'll change the X value in the part off. So 1,000's fine, it won't throw the workpiece. All right. So the other thing is in stock update, we want to make sure that we keep the separated piece. That's what we want to keep. We don't really care about the separated stock over here, so hit green check. Cutoff parameters, everything here should be okay. From stock is good for entry. Corner geometry, we'll put a radius of 15 thousandths. Now I know we're going to end up facing that, but it's nice to not have to handle a bird part. Lead in, lead out should be okay. I'm not going to bother pecking for this workpiece, so we'll hit green check. And that is what we're looking for. So if we backplot this, notice this part is gone. This is all we're working with. That's the stock. See the gray sort of dotted line around it. And that's the reason why I don't, program it to leave the spud. You can, and you could do stock models and work around it. The default jaws don't necessarily simulate right and things like that. So it's just easier to do it this way. And then if you do, if you want to break this off, leave, 200 thousandths diameter here at the machine. So you would change the X value in the code, and that would be after posting, obviously. And then you can just break it off by hand, and then the same programs work later on. So as from a Mastercam standpoint, this is what I would do. I would just change it at the machine tool. So let's go ahead and backplot this. Make sure you don't have any issues. Looks good. So good time to save. And let's verify this now. All right, so we're in verify. I'm going to slow it down quite a bit, and we'll take care of the facing, the rough turning, finish turning, and parting. So there's our workpiece.
All deburred. There are no sharp edges. And now we're ready for our stock flip operation. So again, save again, and I'll transition here and we'll take care of our stock flip. Alright, let's take care of the stock flip operation. So let's reposition the workpiece and the jaws. So let's do a new toolpath group. And let's just name Op2. And then we can go to the part handling operations, go to stock flip. Alright, for the geometry, we got to make sure we select everything here. So make sure you go to levels and make sure both are on. And I'm just in a window and highlight everything for this one. Offset levels by 10 is fine. The transferred position is going to end up being, should be minus 3 inches. We'll double check that. We can always go back and tweak this. In the final position, the diameter is going to be 1.220, and it'll be minus 1.0 because we're going to end up grabbing on this diameter right here. So let's hit green check and see what it comes up with. All right, looks pretty good. That's exactly what we want. Make sure that your top gnomon is on the part and not the stock itself. Make sure that stock is hanging out to the right, because that's going to be what we're looking at. All right, so that's good right there. So there's our stock flip operation. Good time to save. And now let's just do a quick facing op. All right, so we'll go to facing. Select that tool 101. The speeds and feeds from last time should be okay. Face parameters should all be okay. It should be the same as last time. Hit green check. We'll back plot this. Looks good. So there's our facing op. So there's our stock flip and face op. Good time to save. And I'll transition here, just allow you to get through the stock flip and the facing. Come back and we'll spot drill, and bore this hole and finish up this workpiece. Okay, so one thing I forgot to do on this is take care of this corner, because I want to deburr that. We don't have to draw geometry in this situation. We can go into the lathe face operations, go to corner, and we'll put a radius of 15 thousandths. Make sure it looks just like that one, and then hit green check out. Okay, and let's watch this run. Actually, I'll stop and hit S. See how it forms the radius? If we actually go to wireframe in the bottom right, you'll see it form the radius. That's what we want. Okay, so that'll deburr the workpiece for us quickly. All right, it's just something different there. Go back to solid. And now we got to start thinking about, while we're on deburring, is what we're going to do with this corner here. Well, this corner here, I'm going to end up modifying that in solids. So in solids, I'll go to fillet, and this will end up being 15 thousandths. So hit green check. Now we have that done as well. So we just took care of the deburring for this operation. Okay. The only thing we're not going to be able to get is going to be this hole. Now, we could have done that hole in the beginning and then deburred this corner with a countersink or something and then came in here, but it's not worth it. We could do this one hole by hand. It's just trying to make an effort to, deburr while you're in the machining operations. Okay, so now that the facing's done, let's take care of the other op. So we'll go to turning, drill, and I have a 3/8 spot drill already in there, but again, go to select library tools if you can't find the spot drill you want. See how they're not there? What you can do is, I'll just delete this for now. You just right click and create tool. Okay, this is going to be a drill. Name 3/8 spot, 3/8, 3/8, 1 flute. It's a lathe with inches per rev anyway, but that'll work for us. 118 degree. And parameters, make sure the tool name here is 0.375 spot. And then tool 4 is fine, and we'll hit green check. So we'll end up going, let's say, 5 thousandths per rev at a constant RPM of 500 to be okay for us. Max spindle speed will cap at 1,000, although we should not have an issue there because we are at standard RPM, which if my memory serves me right, which should be G97 instead of G96 for constant surface speed. So we'll go into the drilling parameters. The depth, we'll do a finish diameter of 0.360 and overwrite it. All right, that's good. Everything else should be okay. So we'll hit green check, and it looks good. Okay, let's copy that operation and change it up so we're using a drill. So we'll go in here, go to select library tools, And let's take a look at what we have. There's end mills, drills. There's a 1/2-inch drill right here is what we'll use. So we'll hit green check. And then in here, we got to make sure that the tool is the right size. So again, one flute. That's just a habit. It doesn't make a difference for us too much, but it's a habit. Looks like the cutting length is 375, 4 inches there, 5 inches there. This should work fine. So out of the holder, it looks like this is our number here. So the holder is 5 inches, so it looks like we're 3 3/4 out. Again, that should work. All right, so just gotta watch your tool stick out here. So we'll hit green check. These speeds and feeds should be okay. Again, it was aluminum. We're not working about anything totally optimized for a learning environment. As long as you're not breaking stuff, I'm happy. So that's fine for this. So we will go to a peck drill cycle. The first peck, let's go 100 thousandths. Everything else, depth, we'll select over here. And then make sure we drill compensate breakthrough amount of 10 thousandths, something a little bit. Everything else is okay. I'm not worried, I'm just looking in here, we're good there. Then hit green, check. And then we can watch this operation. Notice it goes through. So let's watch the drill operation, not the spot drill, just the drill. Alright. Make sure it goes through the workpiece. And again, instead of watching, you can just hit stop and hold the S. There it is, breaking through 10 thousandths. Okay, so that looks okay. All right, so one thing I forgot here is in the lathe drill for the 1/2-inch drill, I gotta change the number to tool 5. I want them sequential. I could have had that in the initial parameters, but it's just as easy to change it as you go. So that's good. Okay. Let's now, one thing I want to cover before we get into the boring is how do you go between ops in case we get out of order here. Let's say you want to go back to the first op. There it is. What are we missing? The geometry. But the movement of the stock and the jaws occur by where this red cursor is. What about the geometry? That's going to be a view sheet. So let's go back to op 1. Okay. Notice how nothing's there. If we click op 1, it is there. But now if we go to op 2, there's nothing there to tell us that. So let's go ahead and turn the levels for op 2 on, these two here, from the stock flip. Alright, and then let's do a new view sheet as op 2, and right click and save view sheet bookmark. So now what we can do is if we go to toolpaths, we do 1, 1, there we go, there's op 1, go to op 2, turn the red cursor below it, op 2, that's how you're going to go between your operations for this setup. So go ahead and save, and then let's take care of the boring. So we're going to go to a roughing operation. And let's take care of this radius, this way, and work our way over. And if it doesn't let you, you can click over here. Or click the right direction, which I was not. So see how I got double there? Be careful. So here and there should pick up. Okay, so that's good. With a green check. So there's our first op. Okay, as far as turning. So now we go to select library tool. Let's get a boring bar. So let's get a boring bar, minimum 1/4 inch diameter. That's good. Okay, so we'll hit green check for this. That'll give us more room in there. Could use bigger boring bar, but this is fine for us. So let's make this tool 6. And for speeds and feeds, the spindle speed, constant surface speed, let's go 500, slow it down a little bit. And we'll go max RPM, 2000 is fine. Feed rate's fine. Let's go a feed rate of 7 thousandths for this. Let's go to rough parameters. Depth of cut will go 0.25, just take it easy. In case it's your first time running a boring bar on a CNC lathe. Stock to leave is fine. Use stock for outer boundary is fine. Lead in, lead out. Let's lead out, extend it by 20 thousandths. And hit green check. Then hit green check again. Okay. And we could take a look if we go to the wireframe view and we can see our toolpath. If we go to backplot and hit play, speed it up a little bit. You see it roughing the bore. Okay, looks good. So let's take care of the finishing. So I'll turn that visualization off, go to finish, select here and here, or again you can use the arrows, hit green check. We're going to use the same tool in this case. If you're on TL, you'll thank me, you don't have to change the tool manually. We'll put the feed rate to 0.03 thousandths, increase the spindle speed to 500, or let's say 600 ish, just a little bit. Max is 2,000, so just increase a little bit. Mostly it's a feed rate reduction. Again, these are not optimal. We could be cranking aluminum, but if this is the first example we do select for lab, I don't want people being too intimidated. I'd rather have the part come out correct. So finish parameters are fine. Lead in, lead out. Change the lead out to extend it by 20 thou to match the other op. Again, we're going into air this time, so it's not like the same situation with the OD turning. Green check, green check. And notice we are going past the op. Again, don't worry about the blue line being compensated in. That's just tool nose radius compensation occurring. So if you're used to hand programming, you know how cutter comp works in the lathe, and that's exactly what's being compensated automatically because we're using computer comp. So hit green check. One thing to bring up with that is that you need to make sure that you're using the right inserts. So if you open this and look at the insert as far as the corner radius, all that matters. So the corner radius of the insert is very critical because it's compensating for that tool nose radius. Just like you do a hand programmer, you got to tell the machine what it's doing as far as in your offsets, and then what the direction of the tip. This is doing that for you, but you got to give it the right information. So I don't really get into too much of that here because we're not in the shop yet. Just know that you need to make sure that your corner radius on the insert matches, the insert geometry matches what you're doing. Okay, so it's not a big deal because again, there's a lot of different boring bar options in the shop. Just know that if you are in a lab class and you're going to run this part, that the tooling, just like on the mill, is very critical. Okay, even these OD tools, especially with the radii we have going on. So just be aware of that. Okay, so there's a boring bar, green check. All right. So I'm going to hit save. All right, let's get ready to verify this and take a look at some stock flip manipulations. So let's verify this. So first thing you want to do is make sure that update stock is on by clicking it. And then select just the cutting operations, go to verify. You'll see we're grabbing on the diameter. The 3/4 view here is in verify first quadrant, just to look at the ID work. Hit play and work through the workpiece. Rough it and finish it. So that's fine. The key here is watch what happens when you select everything and go to verify. It's going to grab on a different diameter of the stock. See that? Because the stock flip's a toolpath operation. So what I recommend you do in this situation, notice if we go back here and go to verify, we should be good, I hope. There we are. Okay, so now let's separate this out. So I'm going to do a new toolpath group, and this just helps in selection. It's not super important. You could just go like this, hold shift and not select the stock flip. But let's put the stock flip in a separate toolpath group, and now you know why I'm doing that. So let's go to these operations here, select them all, click and drag them down. Okay, so that they're separate. Now this will be renamed stock flip, and this will be renamed op2. So now it's much easier to select op2 view sheet, verify, and you see what's going on. Looks good. Okay. Then if you want to go back to op1, put the cursor here, hit the op1 view sheet, go to verify, and there's all the OD work. Finishing, parting. Okay. So that's about it for this one. Again, your organization as far as what you're viewing is a little different than the mill. So this is op1. If you want to go to op2, bring the red cursor below it and go to the op2 view sheet. If you want to go back, bring the cursor below on op1, go to the op1 view sheet. And where the red cursor is kind of goes through the chain of how the stocks disappear. So that's really it for this one. Make sure you separate the stock flip. On one of the other videos you'll see I automatically do that, but I wanted to give a reason why. That is the reason why. Watch out for that update stock option. That could curse you because it's not really in your face. So just leave that alone. Leave it on update stock and watch your cursor. So again, if we go in the bottom here to opt 2, verify. Looks good. Okay. OD turn. Bring a red cursor up. Opt 1. Verify. We're all set. And again, as far as your toolpath simulation, just turn them on or off as you normally would. Okay. So that's about it for this one. If you have any questions, let me know. And thanks for watching.